Okay, we're going to look at something a little different. We're going to get into some sequences and series. Okay. We're going to look at how to write these things. We'll take a look at factorial notation, which you've likely seen before, but we'll look at how to simplify it. And then we will get into summation notation and infinite series. Okay, so a sequence is simply a list of numbers. It is a function, and there is a relationship between the numbers. Um, but the way we write this is with subscripts. So if you see what we have here, um, the first term, I'm going to label it as 1, in our sequence, we refer to as a sub 1. Okay, the subscript gives you the number of the term in this case. So this would be our second term, third, fourth, and so on. Okay. Interestingly, if you think of this as a function, the domain or the x values of the function are these subscripts. Okay, so we say that the domain of a sequence is often the positive integers only. Okay, so we only have 1, 2, 3, 4, and so on all the way up. Now, each of the a values, again, are terms of the sequence. There could be any value depending on how the sequence is defined. And we call this a finite sequence if it ends. In other words, if this keeps going on and just doesn't end, there are an infinite number of elements or terms of the sequence, then it's an infinite sequence. If it's just something like 1, 2, 3, 4, and it stops, that's a finite sequence. Okay, so let's practice and look at figuring out what the terms are. We want the first 4 terms of the sequence. Now we're going to start numbering with 1. Sometimes you will see sequences that start numbering with 0. Either one is okay. If you start numbering with 0, obviously your subscripts are not going to match. They're going to be off by 1. They're not going to match your term numbers. Okay, but let's do a sub 1. In this case, we're going to plug it in. It's going to be 3 times 1 minus 2 is 3 minus 2, or 1. So our first term, a sub 1, is 1. A sub 2 is going to be 3 times 2 minus 2. It's just plugging in like you would into a regular function. It's going to be 6 minus 2, or 4. A sub 3, 3 times 3 minus 2, following the rule, equals 9 minus 2, or 7. And a sub 4 is going to be 3 times 4 minus 2, or 12 minus 2, which is 10. Okay, so here are the first 4 terms of our sequence. Okay, it's a sub 1, a sub 2, a sub 3, and a sub 4. Okay, I'm not going to do all 4 of these, but let's practice. This should be a subscript. This should say a sub n equals 3 plus -1 to the n power. Okay, so a sub 1 is going to be 3 plus -1 to the first. Okay, well, -1 to the first is -1. Okay, so it's going to be 3 plus -1, or 2. Okay, let's do a sub 4. It's going to be 3 plus -1 to the fourth. Now, -1 to the fourth is going to be +1. So this is going to be 3 plus 1, which is 4. Okay, of course, we'd figure out a sub 2 and a sub 3 as well. Okay, so now we're going to work backwards and we're going to try to figure out, okay, well, what is the relationship? What expression defines the sequence? Okay, so if you look here, each time we are moving to the next number, in this case, it looks like we're adding 2. Okay, so let's number our terms. That's term 1, term 2, term 3, and term 4. Okay, and we want to define this as a sub n equals something. Okay, we want to know what that relationship is. Well, here it looks like a sub n equals n, but that's not true here. Here it's n minus 1, here it's n minus 2. Okay? So looking at this, can you figure out a um, a pattern? Can you figure out a function that defines the relationship between these x values, what you could think of as those x values, and those y values? Okay, well, if you look enough, you're going to realize that it's 2n minus 1. Okay, and this is the same type of thing you probably did back when you started learning functions many moons ago. Okay, well, let's look at the next one. The next one's interesting because notice the sign changes. And the way we can make the sign change is to use -1 to a power. Okay, here we want the odd numbers. This is again 1, term 2, term 3, and term 4. We want the odd powers to be positive and the even powers to be negative. Okay, so the way we do that is we can say -1 to the n plus 1 or n minus 1. It doesn't really matter, but that'll just make the even ones come out to be positive. I'm sorry, the even terms be negative. Think about it. If this is -1, if it's the third term, it will be -1 to the fourth, which is a positive number. Okay. Now we need to figure out, well, how do we move from term to term? And if you look at it long enough, you're going to realize what you've got is n squared plus 1, and this would define a sub n. Okay, bit of a puzzle to figure some of these out. Going back to this, really, if you wanted to check this, obviously you could plug in each of the numbers. Let's try the first one. You'd have -1 to the 1 plus 1 is 2 next, so -1 squared times n squared, which is 1 plus 1, which is 1 times 2, which is 2, and that matches what we have here. You check all the terms just to make sure that everything is okay, because it is possible to get something that works for the first one, but not the others. We can also define sequences in what we call recursive manner, or define them recursively. And what this is you're defining the sequence based on the prior numbers. So if we go back here and look at this first example again, notice that we realize that we could add 2 to each one to get to the next one. So you could say that a sub n is equal to a sub n minus 1 plus 2. Okay? Means any value. Okay, now the problem is the first value you'd have to give. Okay, but once you have that first value, if you're looking at a sub 2, which would be this one, 3. Okay, a sub 2 is going to be equal to a sub 2 minus 1. That'll be a sub 1 plus 2. Well, a sub 1 is 1. So that'll be 1 plus 2 or 3. And that'll work for all of the terms in that sequence. A famous sequence is this Fibonacci sequence, which is defined recursively. We're given the first two terms. In this case, we're starting off with a sub 0. So we're given a sub 0 and a sub 1. And then we're told that a sub k, any a sub with that variable, okay, is equal to the term that is 2 before it, right? Because if we have terms of a sequence, so let's say we have k, we're going to have the next one is going to be k plus 1, or k plus 2 would be the next one, and so on. Or if we wanted to look at it backwards, if this third term was k, the term before it would be k minus 1, and the term before that would be k minus 2. And that's what this is saying. A sub k, this term, is equal to the sum of the two terms before it. Okay? So let's go ahead and write the sequence. We know that the first term is 1 and the second term is 1. The third term is going to be the sum of the first two. So it's going to be 2. The next term is going to be the sum of the two before it, so 2 plus 1. And so on, 3 plus 2, 5 plus 3. Okay, and now we have the first 6 terms of that sequence. Let's take a look at factorial notation. You've seen this before. Um, a number factorial is just equal to all of its counting numbers multiplied together. So in other words, 4 factorial is simply 4 times 3 times 2 times 1. Okay. As a special case, it's important to recognize 0 factorial is defined as 1. Okay, so if you have 0 factorial, just count it as 1. Okay. So let's go ahead and practice. We want the first 5 terms of a sequence defined like this. All right, so a sub 1 is going to be equal to 2 to the first. So just plugging in that 1 anytime I see an n over 1 factorial, which is 2 over 1, or 2. So a sub 1 is 2. A sub 2 is going to be 2 to the second power divided by 2 factorial, which is 4 divided by 2, which is 2. Again, a sub 3 is going to be 2 to the third divided by 3 factorial, which is 8 divided by 3 times 2, or 8 divided by 6, which reduces to 4/3. Okay, and we can continue on in this manner, just plugging in, working through, and figuring out what the terms are to figure out A4, A5, and so on. Okay, we'll take up in the next video, starting with summation notation.